Hello everyone. And I was a little bit shocked when I found that almost everyone didn't know about how to utilize Jetsons nowadays. When I asking people simple question, are you running your neural networks on DLA on Jetson or on GPU? They looked on me with suspicion and asking what is the DLA. Do you know that it's like about 60% of performance for Orin NX, and it's even more for Orin AGX? Let's like in few words describe what is NPU. It's the basic ASIC chip where all matrix operation they already baked in this chip, and all this matrix operation, they already optimized for neural network. Of course, it's much more efficient than GPU in terms of energy for one operation. Of course, it's like doesn't support all available neural networks architectures. Of course, such models, they are a little bit harder to utilize. Sometimes you need to optimize your neural network, sometimes you need to optimize your data structures, and so on. Some neural networks doesn't work out of the box with these NPU chips. But these NPU chips provide you super efficient computational, and for example, for Orin NX, you have just 3 independent devices in the same board. Each one of them has almost the same performance. And when you just running your neural networks on GPU, you basically ignore like 60% of power. NVIDIA calls them DLA. It actually doesn't like block GPU inference. You can run in parallel 2 inference on DLA and 1 on GPU. Of course, it's like a little bit more complex when you like go to the details, but in general, all these DLA, they extend your existing performance. Some neural networks, they are pretty hard to run on DLA. For example, like modern LLM, it's a complex task, and I don't think that it's possible to run like every LLM on DLA, but for some LLMs, it's possible like to run them partially, like for example, visual part or so on. Today, there are 2, in my opinion, it's just 2 ways of usage of DLA. Of course, there are much more of them, but in general, they use basically the same drivers, the same libraries from NVIDIA. But like these approaches, they are a little bit different, in my opinion. And I just want to start from the basic approach from NVIDIA and tell a little bit more like about inference with trtexec and with polygraphy, Python inference. Okay, and let me show how to use all this stuff. Right now, this Jupyter is running on the Jetson. So first of all, I of course initialize where is my trtexec. And with trtexec, it's super easy to export any model. Right here, it's just base ResNet model. And to export it, we just need to write this simple command. Of course, this export, it's for GPU, and I did this just for comparison. And as you can see, for comparison, the speed that we will have here, it's around 2.2 milliseconds per one image. This without like additional cost like enqueuing and so on. So the full time should be around maybe 4 millisecond. It's in the mode when we're starting and just waiting for the final release. Maybe a little bit less. If we will run the same stuff on DLA, we just need to put here like use DLA core. I save all other commands the same. And the result after the export will be pretty bad, I expect. Yes, 10 times longer. It's pretty strange. You probably will ask why. The main difference because here I'm utilizing DLA with FP16. And actually DLA is faster, is comparable only on int 8. And if we will put here into 8, the speed will be pretty reasonable. It should be around the same timings. Yeah. Even faster than FP16 for GPU. But the main question that this speed, this network will not work. Why? Because with this trtexec command, you need to provide calibration file that should be utilized. And create this calibration file, actually, to create this file, you need to run the calibration once with Python. And here it's like example. Of course, it's doesn't work because I created dummy calibration here. You need to install polygraphy, and here it's just the simple code that will create dummy calibration data and run this calibration and calculate even some timings. So in general, with this calibration file, if you will provide to this script, to provide this calibration file in the script, you need to append, I think, somewhere like this, calibration, and the name of our file is... Do I need to provide? Probably not. Yes. And this will be run with this calibration file. But here as well, with this Python, you can save same calibration, same engine and same calibration file, of course. So probably it's easier just to calibrate with Python. But if you need to run this on the Jetson directly without installing all Python libraries, this one approach will work as well. So let's wait a second. Yes, it should be already work. But the speed shouldn't change in general. It should be the same. Yeah, it's the same speed, of course. Also pretty interesting that, of course, speaking of the speed, if you will put, like for the base TensorRT, you will put int 8 here, of course, it will be faster, much faster than DLA, but performance on 2 DLA unit should be faster than performance on 1 GPU. So let's wait a few seconds. Here, as you can see, we also didn't provide any calibration data. So this result, yes, calibrator is not being used. And this result actually will not work for the real file. You need to provide the real calibration data, of course. And to prepare your real calibration, you need to write here your data load and yield this as your data. Yes, it's a little bit faster than 1 DLA model. Okay, and the second approach is directly approach with Pytorch, which is support today TensorRT, but I didn't met a lot of discussions like of limitation of this approach. So it's like a little bit questionable, will everything work or not? The other way to utilize your DLA unit, it's actually through Torch-TensorRT inference. To utilize this inference, you need to install this Torch-TensorRT library with your Torch. And here it's a little bit different structure, of course, of quantization and so on, because as you already know, for DLA usage, you need to use quantization. Here is like approach how to calibrate. It's maybe a little bit different from what I previously showed to you. And of course, here it's like DLA model where you can just compile your Torch script model that will utilize DLA on your device. Okay, here was my small guide about how to use DLA. I hope it helped you if you didn't know this. But in my opinion, it's like super important to utilize like all performance of your platform if you are really using this platform. So, and in case if you just don't this performance, just take a cheaper platform and so on. So thank you for watching. Bye.